When we mention elastic materials in physics, we're usually talking about problems involving springs and Hooke's law. So before I get into Hooke's law, I'll just take a little bit of time to go over the basics of some elastic materials which can be used for application in problems using Hooke's law. So first of all, elastic materials obviously can restore back to their original shape. And this is done through the force called the restoring force, which can also be abbreviated as F sub int max, which is the maximum internal force of the object. And it's important to note that this force, the restoring force, always acts in the direction that's opposite to the displacement or deformation of the object. For example, if I pulled down on the spring, then the restoring force would counteract that pulling down and try to bring it back up to its original shape. Now, as for Hooke's law, it takes into account the force, something called the spring constant, and the displacement of an elastic material or spring. And it takes all of these variables and puts them into a nice little relationship for us so that we can use it for various problems. So Hooke's law is written as F equals K times delta X, and F here is going to be the force. K is our spring constant, which is measured in newtons per meter, and delta X is going to be the displacement. So for an example problem, let's do a spring is attached to a ceiling, and there's a weight attached to the bottom of the spring, which makes it stretch by a distance of 0.03 meters. All right, and we're trying to find the value of the spring constant in this problem. And the weight of this weight, I guess, is 1 kilogram, or the mass of this weight. Okay, so now we can use these variables, 0.03 meters and 1 kilogram, in order to find the spring constant by plugging them into the respective variables up here. But we do have to be careful because we are given the delta x, which is 0.03 meters, but we do not know the f, so we just have to find a way to substitute some other variables in for f in order to solve for k. So let's get into it, and since we already know what delta x is, we can just check that off. And now to find the force, we'll have to use Newton's second law, which states that force is equal to mass times acceleration. So the force that this weight is applying onto the spring is going to be its mass, which we know is 1 kilogram. And since the mass is going to be pulled down by the acceleration due to gravity, we can use little g and substitute that in for the acceleration. So that's going to be 9.8 newtons per kilogram. So now we can solve for the force, which is going to be 9.8 newtons. All right, so now that we know the force, we can plug that in back to here and use it in Hooke's law. So the force we said was 9.8 newtons, and that equals the spring constant times the displacement, which is 0.03 meters. And we'll divide both sides by 0.03. So 9.8 divided by 0.03, and that gives us about 327 newtons per meter. And that's our spring constant. So that's a pretty simple but common problem that you'll see in most physics classes. And if you have any questions, just let me know in the comments.